Welcome back. Properties of parallelograms. So 6.2 properties of parallelograms. Now, key things we're going to be going over here are parallelogram, what is a parallelogram, and all of the different things that go with a parallelogram. So first, what is a parallelogram? Quadrilateral is a parallelogram if the opposite sides are congruent. Actually, first, let's get into a definition of parallelogram. We didn't have that written down. The definition of parallelogram is if it's a quadrilateral, so it has four sides, and the opposite side lengths are parallel. So this is by definition what a parallelogram looks like. Opposite sides are parallelogram, or opposite sides are parallel in a parallelogram. If we know a shape is a parallelogram, then we know all of this information is true. If we know it is a parallelogram, then opposite sides are congruent. If we know a quadrilateral is a parallelogram, then consecutive angles are supplementary. Consecutive angles would be, like in this picture, x and y. So what this one is saying that x plus y is equal to 180. If you know it's a parallelogram, then opposite angles are congruent. So if this is angle y, that means this also is angle y. So it doesn't matter which consecutive, so angles next to each other, angles next to each other are going to be congruent. Last but not least, if the quadrilateral is a parallelogram, then diagonals bisect each other. What does that mean? In this picture, if my diagonal and are here, that means these two are going to be congruent, and these two are going to be congruent. So this point cuts the two lines in half. If this is a parallelogram, then that point cuts them in half. So these are all properties that I would star because you're going to have to just know these. These are ones that you should study. So in this question, it says, what is the measure of angle R in this parallelogram? So first it has to tell us it's a parallelogram. So I look back at my properties. Well, these angles are consecutive, and I know consecutive angles are supplementary. So I could say 71 plus angle R is equal to 180. And if you're going to solve that, the opposite of adding, because this is a positive, would be subtracting 71. So angle R would be equal to 109 degrees because consecutive angles are supplementary. Problem 2. It says, oh, where is my question? What? Well, it says this is a parallelogram because my opposite sides are congruent. So even if we didn't have it stated that it's a parallelogram, I know by definition my opposite sides are parallel. So it's a parallelogram. Usually we'll ask what is the value of x and what's the value of a. So in this picture, my x values are here and here. Opposite angles in a parallelogram are congruent. Opposite angles are congruent. So we can write up the first equation that 5x plus 40, 10x minus 35 is equal to each other because they're opposite angles. So pause the video. I want you to solve for x. So I know that x is equal to 15. Now I also have to figure out what a is equal to. A is this angle right here. Well, I also know that consecutive angles are equal to 180. So I can plug x back into my equation right here. And if I plug 5 times 15 plus 40 into this, this is going to be 115. So this angle or this angle, doesn't matter, are equal to 115. Now consecutive angles are equal to 180. So I can say 13a plus 115, because that's consecutive, equals 180. I want you to pause the video and solve that equation. So you subtract 115, divide by 13, so you're working the opposite on this side to bring to the other side. You get a is equal to 5. Problem 4 or 3. Can you count, Mrs. Frickman? Yes, I can. So it's saying, what is the values of a and b? Now, here, if this is a parallelogram and it's telling us it is, then the diagonals bisect each other. That's another property. So this is going to be congruent to this. So I can write up that equation. A is equal to 2b minus 8. I also can say that this is equal to this. So b is equal to a plus 2. Now we've done problems like this in before. So both of these equations have a and b. So what I'll have to do is plug this, it doesn't matter which one, but I'm going to plug this into this equation for b, because b is equal to this. And this a and b has to be the same thing because it's the same problem. So I'm going to, instead of writing b there, I'm going to have 2 times what b is equal to, a plus 2, and then minus 8. So I'm plugging this in for b. Now, if I solve this, I have a equals 2a, I have to distribute that to both. So I'm going to subtract a. So I have negative a is equal to, I'm going to combine these two like terms. Negative 4, divide by negative 1. A is going to be equal to 4. Now I can use that, because now I can use that right here. So b will be equal to 4 plus 2. So b is equal to 6. So again, first setting up the equations and plugging one into the other. And my final. Now, we didn't really say anything about these angles here. However, this is a parallelogram. So if this is a parallelogram, we know that these two are parallel. So one thing about this picture, I can say that in that Z right there, these two are alternate interior angles because these two lines are parallel. So if this one's 42, this one has to be 42. I know that for sure. If this is 173, here's a straight angle right there. So I can figure out what this angle is or what this angle. Because I'm going to do 180 minus 73. This is going to be 107. 180 minus 73. So angle 1, these two are vertical. So angle 1 will also be equal to 107. Same thing here. Here's that straight angle. Here's a straight angle. So 180 subtract 73 is 107. Now I have this triangle right here. So I can say angle 3 plus 42 plus 107 is equal to 180. So angle 3 is equal to 31. Now we still have to solve for angle 2. However, looking at this picture, if I drew this Z right here, that means these two angles are the same because of those pinchers when we have parallel lines. So angle 2 is also equal to 31. So we have angle 1, angle 2, angle 3, bing, bada, boom. Have a great and wonderful day.